Encryption at rest is the encoding or encryption of data when it is persistent. For a data store to be considered persistent, it must write to non-volatile storage. The encryption at rest designs in Azure use symmetric encryption to encrypt and decrypt large amounts of data quickly. A symmetric encryption key is used to encrypt data as it is written to storage. The same encryption key is used to decrypt that data as it is readied for use in memory. Data may be partitioned and different keys may be used for each partition. Keys must be stored in a secure location with identity-based access control and audit policies. Data encryption keys are often encrypted with asymmetric encryption to further limit access. Encryption at rest is designed to prevent an attacker from accessing the unencrypted data by ensuring the data is encrypted when on disk. If an attacker obtains a hard drive with encrypted data, but not the encryption keys, the attacker must defeat the encryption to read the data. This attack is much more complex and resource-consuming than accessing unencrypted data on a hard drive. For this reason, encryption at rest is highly recommended and is a high priority requirement for many organizations. Encryption at rest may be required because of an organization's need for data governance and compliance obligations. Industry and government regulations such as GDPR or PCI DSS lay out specific safeguards regarding data protection and encryption requirements. Encryption at rest is a mandatory measure required for compliance with some of these regulations. In addition to satisfying compliance and regulatory requirements, encryption at rest provides defense in depth protection. Microsoft Azure provides a compliant platform for services, applications, and data. It also provides comprehensive facility and physical security, data access control, and auditing. However, it's important to provide additional overlapping security measures in case one of the other security measures fails, and encryption at rest provides such a security measure. The objective of encryption at rest is that data persisted to disk is encrypted with a secret encryption key. To achieve that goal, you must provide an environment for secure key creation, storage, access control, and management of the encryption keys. The storage location of the encryption keys and access control to those keys is central to an encryption at rest model. The keys need to be highly secured but manageable by specified users and available to specific services. For Azure services, Azure Key Vault is the recommended key management and storage solution. Keys are stored and managed in key vaults. Access to a key vault can be given to users or services. Azure Key Vault supports customer creation of keys or importation of customer keys for use in customer-managed encryption key scenarios. Permissions to use the keys stored in Azure Key Vault, either to manage or to access them for encryption at rest, encryption and decryption, can be given to Azure Active Directory accounts. More than one encryption key is used in an encryption at rest implementation. Asymmetric encryption is useful for establishing the trust and authentication needed for key access and key management. Symmetric encryption is more efficient for bulk encryption and decryption, allowing for stronger encryption and better performance. Limiting the use of a single encryption key decreases the risk that the key will be compromised and reduces the cost of re-encryption when a key must be replaced. Azure encryption at rest models used a key hierarchy made up of data encryption key and the key encryption key. A data encryption key is a symmetric advanced encryption standard 256-bit key used to encrypt a partition or block of data. A single resource may have many partitions and many data encryption keys. Encrypting each block of data with a different key makes cryptanalysis attacks more difficult. Access to the data encryption key is needed by the resource provider or the application instance that is encrypting and decrypting a specific block. When a data encryption key is replaced with a new key, only the data in its associated block must be re-encrypted with the new key. The key encryption key is an asymmetric encryption key used to encrypt the data encryption keys. The use of a key encryption key allows the data encryption keys themselves to be encrypted and controlled. The entity that has access to the key encryption key may be different from the entity that requires the data encryption key. An entity may broker access to the data encryption key to limit the access of each data encryption key to a specific partition. Since the key encryption key is required to decrypt the data encryption keys, the key encryption key is effectively a single point by which data encryption keys can be effectively deleted by deletion of the key encryption key. The data encryption keys encrypted with the key encryption keys are stored separately, and only an entity with access to the key encryption key can get any data encryption keys encrypted with that key. The supported encryption models in Azure are split into two main groups: client-side encryption and server-side encryption. Independent of the encryption at rest model used, Microsoft recommends the use of a secure transport such as TLS or HTTPS. Therefore, encryption in transport should be addressed by the transport protocol and should not be a major factor in determining which encryption at rest model to use. The server-side encryption model refers to encryption that is performed by the Azure Storage Service. The resource provider performs the encryption and decryption operations. For example, Azure Storage may receive data in plain text operations and performs the encryption and decryption internally. The resource provider might use encryption keys that are managed by Microsoft or by the customer depending on the provided configuration. For many customers, the essential requirement is to ensure that the data is encrypted whenever it is at rest. Server-side encryption using serviced managed keys enables customers to indicate the specific resource for encryption and delegate key management operations such as issuance of keys, key rotation, and key backup to Microsoft Azure. The Azure resource provider creates the keys, places the keys in secure storage, and retrieves the keys when needed. Server-side encryption using service-managed keys therefore quickly addresses the need to have encryption at rest with low overhead to the customer. In many cases, an organization may determine that resource constraints or risks of an on-premises solution may be greater than the risk of cloud management of the encryption at rest keys. However, this model might not be sufficient for organizations that have requirements to control the creation or lifecycle of the encryption keys, or to have different personnel manage a service encryption keys than those managing the service. That is, segregation of key management from the overall management model for the service. The server-side encryption model with customer-managed keys in Azure Key Vault involves the service accessing the keys to encrypt and decrypt data as needed. Encryption at rest keys are made accessible to a service through an access control policy. This policy grants the service identity access to receive the key. An Azure service running on behalf of an associated subscription can be configured with an identity in that subscription. The service can perform Azure Active Directory authentication and receive an authentication token identifying itself as that service acting on behalf of the subscription. That token can then be presented to Key Vault to obtain a key it has been given access to. For operations using encryption keys, a service identity can be granted access to operations that allow it to decrypt or encrypt and much more. With server-side encryption using customer-managed keys in Azure Key Vault, the customer has full control over the keys used. Encryption keys are managed in the customer's Key Vault under the customer's control. The customer has the ability to encrypt multiple services to one master. The customer can segregate key management from the overall management model for the service and can define service and key location across regions. On the other hand, the customer has full responsibility for key management access and lifecycle management. There is also additional setup and configuration overhead. Some Azure services enable the host your own key management model. This management model is useful in scenarios where there is a need to encrypt the data at rest and manage the keys in a proprietary repository outside of Microsoft's control. In this model, the Azure Storage Service must retrieve the key from an external site. Performance and availability guarantees are impacted, and configuration is more complex. The service has access to the data encryption key during the encryption and decryption operations. Hence, the overall security guarantees of this model are similar to when the keys are customer managed in Azure Key Vault. This model is not appropriate for most organizations unless they have specific key management requirements. Due to these limitations, most Azure services do not support server-side encryption using server-managed keys in a customer-controlled hardware. Finally, the client-side encryption model refers to encryption that is performed outside of the resource provider or Azure by the service or calling application. The encryption can be performed by the service application in Azure or by an application running in the customer data center. In either case, when leveraging this encryption model, the Azure resource provider receives an encrypted blob of data without the ability to decrypt the data in any way or have access to the encryption keys. In this model, the key management is done by the calling service or application and is opaque to the Azure service.